Welcome, dear students. Now we discuss question number 3 for the year 2023 Probability Statistics, paper CC11, semester 5, CBCS. Question number 3. A point P is taken at random on a line segment AB of length twice A. Find the probability that the area of the rectangle AP into PB will exceed a square by 2. So this is the straight line. The straight line, this point P, this point A, this point B, and this point is P. And from this, suppose this is the x-axis, this is the point A, this point B, and total length is this twice A. Suppose this is origin, and this is the point B. Length is twice A. Say this is the twice A length. So P is distance from A is x. This is x. So obviously this distance is 2A minus x. The question is that capital X be a distance, random variable, distance for the random variable capital X from the point A to point P. Since the point is taken at random on the line segment AB of length twice A. This random variable capital X is a continuous random variable following the uniform distribution on the interval over close to interval 0 to twice A. The probability density function for this fx equals to 1 by 2a minus 0. That is 1 by 2a for 0 less than equal to x less than equal to 2a. This x represents the random variable corresponding to the point, this point distance from this point. Suppose this point is origin, so this distance twice a, and this distance from the origin to x. The lengths of two segments are AP and PB, to AP equal to x and PB equal to 2a minus x. The area of the rectangle, this is the x AP into PB, that is this is the AP into PB, this is the AP into PB equal to x bracket 2a minus x. This is the area of this rectangle formed by these two sides AP into PB. This forms a rectangle. So area is AX. Now the question is that find the probability that the area of the rectangle AP into PB will exceed a square by 2. Area will exceed a square by 2. So area is this, probability of the area, this x into 2a minus x is greater than a square by 2. So after simplification, we get from this inequality probability of this x square minus 2ax plus a square by 2 less than 0. First we simplify this inequality taking equal to 0. We get solving this x equals to a plus minus a by root 2. So the inequality is satisfied. This less than equal to 0, this inequality. So from this inequality we get this x, when this x satisfies the less than 0, so this x lies in the interval a minus a by root 2 comma a plus a by root 2. So x, so random variable of this probability of this random variable between the limits a minus a by root 2 less than capital X less than a plus a by root 2. So from this we get this. Actually this is the wrong. Under this probability this must be capital X. So this capital X, this capital X, and this capital X, this capital X, this random variable is this, and not real variable this. So capital X into 2a minus x greater than a square by 2, probability of capital X square minus 2a capital X plus a square by 2 less than 0. So we get probability of this. So this is the definite integral lower limit this to this fx uh, probability uh, density function for continuous distribution fx equals to 1 by twice a. So we get 1 by twice a dx. So twice a into x, lower limit a minus a by root 2, upper limit a plus a by root 2. So we get 1 by root 2. The required probability is 1 by root 2. Now we can alternatively we can find this probability in this way. The length of this interval is this a plus a by square root 2 minus a by root 2. So this is equal to a root 2. This is the favorable length when x point P lies in this interval a minus a by root 2, a plus a by root 2, then x this is the favorable length of the interval of this. The probability is the length of the favorable interval divided by the total length of the segment twice a from a to b. This is the total length. So probability a root 2 by twice a, this is equal to 1 by root 2. You can avoid this integration. You can write this way. Now extra note that this is the line segment. This is the line x-axis. This is the vertical axis is the area, denotes the area. So this is the point 0, origin 0, and this point B is twice a. So coordinates is twice a comma 0, and this 0 0. Now corresponding when point P lie in this point, so corresponding this AP and this distance PB, and corresponding height, this gives the area, corresponding area. This red curve denotes the area x bracket 2a minus x. This is the area. So when point P is here, corresponding PA into PB represents this area. This is the height, corresponding height. And for this, if a point P lie at this point, this, so AP into PB, this the represents this corresponding height. So this graph, red curve, represents the area of the rectangle AP into PB. Actually, it is a parabola with maximum at this x equal to a. This is the point, midpoint of a and b. This is the point a. So this is the, if you put here x equal to a here, so a into 2a minus a, so this is equal to a square. The corresponding maximum a when x equal to a, and when p is here in the midpoint, so height is a square. This is the reference, this point is a square. So from corresponding a by root 2, actually this threshold is a square by 2. The orange dashed line is the represents the threshold is square by 2 because we want to find the area of the rectangle will exceed a square by 2. So corresponding this point, this height is a square by 2. This height is a square by 2. So corresponding area, we want to find the area greater than a square by 2. For that, P lies in this green segment. This is this corresponding a minus a by root 2, a plus a by root 2, corresponding, this is the favorable length, this favorable length, and this corresponding length of these favorable points for which the area is greater than a by 2. For this point, area is this point, this is square by 2, this height is square by 2, and this height, corresponding height is square by 2. This a root 2 is the length of this green segment, favorable length of this, and corresponding height is square by 2. So we want to require to find the area when in this is shaded area, and the favorable region on the x-axis. If the point P lands within the green segment, the resulting rectangle area will exceed a square by 2. So the required probability calculated as the length of the green segment a root 2 divide the total length of the blue line twice a. This is the blue line from A to B. So by this graphing calculator, we get the result. Thank you for watching this video.